Okay, second video. We're going to get down and dirty with the two main connectors, really the only connectors you have to interface with on a Duramax swap in a swap situation where you're going to be cutting these wires and attaching them to things on your actual vehicle. What we have here is what you'll call the X2 connector. It goes underneath the very large junction block that kind of has all the relays and fuses under hood. This is kind of a bottom view of it. You can see this connector is called X2. You've got to have factory wiring service literature. You can't fake it. You've got to get it. It's going to show you all the pinouts, pin labels, and then GM shows you, terminal position, size of the wire, color of the wire, circuit number, and then kind of a brief description of its function. On this particular connector here, this goes to the fuse block. So as you can imagine, they're not passing, stuff like malfunction indicator light or gauges or anything like that. They're passing power. This is where power goes from the fuse block and relay block into the harness. So you're going to see things in here like battery power to the ECM, switched power to the ECM, relay control that the PCM controls in the fuse block. This is power stuff. Now this other connector here, this X109, this is where you're going to see more of low voltage kind of stuff passing from this main engine harness to the rest of the vehicle. So start with this one here. We've got a lot of pink wires here. Fortunately, GM kind of keeps to their own color conventions. Pinks are usually an ignition power wire source. So when the car's off, they're off. When the key's on, they're on. There's lots of pinks. Pink, 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 pink. And they all say ignition 1 voltage. Doesn't necessarily mean they're all the same thing. So while this gives you a clue as to what the function of the wire is, you have to dig deeper to get the actual function, find out what circuit it's on, and if it needs to be fused separately than the others. You can't just cut all the pinks off and hook them together. And through here I have gone through and labeled all my wires. You've got to label with tape, pen, cut them off. You got to label everything. Don't cut anything off. You need to know where it was from and what its function is. It's going to help you tremendously. You got to have your harness to this point before you start cutting anything. I've gone through and found out this yellow with black wire is the starter enable relay control. PCM has control over this to actually trigger the starter wire. Here's one. I have no idea what it is. In the diagram from GM, there's nothing there, so we're going to have to do that the hard way. Some other things that you're going to find in here: AC clutch relay. This is the PCM controlling the AC clutch that is in the main relay box. Then this is plus voltage to turn the compressor on. So this is a control signal from the ECM. This is the power then going to the clutch. Everything in this is going to be power related, fused, relayed power. This right here is plus battery voltage. GM tends to use a red with a white stripe for plus battery voltage. This is going to be a keep alive kind of signal. This has always got battery power. That's all on this side here. This big purple one, you might guess, starter solenoid. So this is going to be the power coming out of the starter relay in the relay box and then going to the starter terminal. That's everything on that side. Then over here you got a bunch of pinks. Some of them are all together. These go to 3 separate power feeds on the ECM. This is controlled by the powertrain relay, and these are all 3 fused on their own 25 amp fuse. And that's why they all then have the same circuit number, 1439, 1439. This is really the big power to the ECM. This is probably going to carry most of the power of the injectors, etc. They're large gauge wires. They're on a 25 amp fuse, which is pretty big, and they are controlled by the powertrain relay. This one right here, another pink wire. This one is, also ignition 1 voltage, different circuit number. This one happens to be called in the diagram throttle control. So this may be power that is used to activate that DPF electronic throttle. That's fused on a 15 amp fuse, also controlled by the powertrain relay. You have a ground here. This ground passes through and goes to one of the grounds on the engine block. Not quite sure of this function yet. I have to trace it down. You've got another pink here that I've isolated and figured out that its function is to go to the mass airflow sensor, that Hitachi. It's on a 15 amp fuse. It's got its own circuit number. Some of the other pinks here, this one goes directly to the fuel heater. I believe that the fuel heater has its own thermostat, so once the fuel reaches a certain temperature, the fuel heater would turn off. I've removed the fuel heater. I've removed the entire fuel filter, since I'm using an external lift pump air dog system, so I won't even be powering this because my fuel heater is going to be completely removed. Make our way through the rest of the pinks here. I don't know what that pink is. I guess I missed that one. Fuel pump relay control. This is probably not used on my donor truck. My donor truck had one tank. I believe the fuel pump on the dual tank trucks just transferred fuel from the rear tank to the front tank. So maybe as the front tank got low, it would turn this on and would pump some fuel from the rear tank to the front tank where the dip tube was. But I won't be using that. Here is another pink, ignition 1 voltage, yet another circuit number. This one I've traced down is going directly to the glow plug control. This goes to a different relay, which is a run crank relay. So that one may be live while running and cranking. So obviously you would want the glow plug to be activated while cranking. So while these are on the powertrain relay, which probably doesn't come on, well, it may come on while cranking. It's just a different power feed than this one. Then once again, we've got a couple red with whites. This is a battery plus voltage. This is most likely the keep alive for the actual PCM and TCM. One may go to the PCM, one may go to the TCM. This they call a true cruise/TCC signal. My guess is this is the last ditch. Turn off the cruise, please. The brakes are on. So this would probably get wired to the brake lights. I'll have to dig further into the lights section to see if this is just wired to the brake lights. And then this one here, powertrain relay coil control. This is the signal that controls the relay, which will then pull down the main engine ignition 1 powers for the PCM. So this will, in an engine swap situation, you're going to have to provide some fused power feeds, for instance, for the battery. Those are just connected to the battery. But then you're also going to have 1 or 2 fused relays. One being this, you'll have to make essentially a powertrain relay and then past it put a 25 amp fuse, and that will be controlled by this wire. That's about everything that you've got on this X2 connector. Next video we'll talk about the X109.